I guess today's presentation I'm actually giving an overview of the ministry engagement in recycling, and that effort basically has been ongoing for probably about 30 odd years. I know my first project when I was in Ottawa, Carleton, that's about 40 years ago, when we do in-place recycling. So the reuse, recycle, and reduce has been ongoing for about 30, 40 years. And in the ministry, we lately just have formalized in the last 3 years or so, multi-ministry get together and everything, and we are looking at ways to do low carbon procurement. By doing low carbon procurement, what that entails is that you now have to look at life cycle costing, and you actually have to look at the environmental aspect of it in order for you to get to the low carbon procurement. In the ministry, the transportation department has been quite progressive in the sense that we actually have used green rating of project that we do for about more than 10 years. The system that we use is actually GreenPave. GreenPave is a technology, is a method that we use how we rate different project itself, and by looking at both the emission reduction, recycling, and carbon footprint itself and innovation, we actually will select that project above and beyond just like lowest cost. In fact, for project equivalent different strategy that you use, plus or minus 10% of the cost, the strategy that have the lowest carbon footprint or GreenPave rating will be selected over the other project, plus or minus even 10% of cost. So it's not just equivalent. We are actually paying a premium for selecting project to design it, construct it in a more environmentally friendly manner, and to that itself, generally recycling is a big component, because if you recycle, the transportation costs, the carbon footprint related to trucking and all those things get reduced. The energy used for basically crushing all those raw material and everything get reduced significantly. And if you do it in place recycling, you are much more further ahead. So in that sense, the ministry actually, at the project design stage, we are already mandated that we actually need to look at different alternatives and which one actually gives the lowest carbon footprint, and that actually is the selection plus or minus 10% of life cycle costing of all the other alternatives. So in principle, the policy is already in place whereby the low carbon procurement is in place. Then once you have that kind of policy in place, then we start to look at what do we need to develop in standard and then specification. So that's basically how the ministry look at the environmental aspect of project itself, is that we now basically have this policy that you actually want to be low carbon procurement. Then what do you need to do, and what are the research we need to do in order for us to facilitate this? So at the ministry, a lot of times, if there's innovative or new technique or new equipment or new process or new material that we want to try, or certain much more product that have no track record itself, we initially will assess the process, the material or the equipment to see does it make engineering sense on the long term. If it does, straight away what we do is that we actually put that project or that equipment into what we call non-standard special provision. We'll write a non-standard provision, and we will identify project from the 5 regions of the ministry, which project we will select to actually try that material or try that equipment or try that process itself. And generally we also understand with any trial and innovation itself, your first project, likely you will hit some challenges. The real intent is that once you do a trial, the NSSP, is it sufficient to actually make it into a specification? If not, what additional changes I need to try in order to improve that specification? Once the engineering office itself determines that that specification now is stabilized enough, we then convert that non-standard provision into a MTO specification itself. And through the working with the GeoCom and QACom, we then basically implement that in terms of what are the spec that is required, and basically what are the QA/QC and the protocol for construction and everything itself will be developed. So in a nutshell, overall, that is how the ministry approached the environmental aspect of road construction to advance it to a low carbon environment. The reason why we actually do it is, I think all of us that have been around long enough, is cost saving is one of it, but definitely a conservation of resources, and basically you actually will get a much more effective use of whatever limited resources that we have. And to be fair, for the next generation, it actually is better for the next generation. And transportation, as I said, on some MTO project, guess what? We are getting material from USA, and some of our aggregate are shipped from Quebec. I think if we look at different way that basically we can reuse, recycle, that will actually limit some of these huge transportation costs and distance costs that is associated with some of the project that the ministry is doing. Other than that itself, in the overall, as I say, in the ministry, when we actually look at the sustainability, cost is just one of it, but as I said, the other thing is also we actually rate what is the environmental impact using the green pave rating system itself, because that actually will give us a real quantification of what is the benefit of actually now going this extra step. And as I said, we would even pay up to 10% premium on the project itself to enforce this much more environmentally sustainable option itself that we are selecting at the design stage. Then basically during the construction, if there's actually an innovation and everything, at MTO contract generally, once we specify something for you to construct, if you actually have other innovation, you can always suggest that back to the ministry, and we will actually evaluate to see what is the benefit to the ministry. And if there's cost saving, is there a split in the cost saving? And if there's no cost saving, if it's environmentally more beneficial for the ministry, likely you will get approved to use the alternative itself. So that even although our specification is set in a certain way that things have to be done, there's always the possibility of basically once you win the contract, for innovation and everything, you can always approach the ministry and basically we will evaluate those. As indicated itself, green pave is a system that we actually use. It's actually based on green road and green light itself, but adapted to Ontario condition. Based on that itself, we actually look at a multiple facet of the thing. As I say, greenhouse gas emission, what are the in terms of material reduction. Based on all those rating itself, we actually will give a project a certain rating in points. And we actually, as I indicated, the key here itself is that it's not the lowest price. In fact, price plus or minus 10%, but with the best green pave rating actually will be the project selection. So that actually will further enhance environmental practice itself at the ministry in road construction. As I say, green pave is now being implemented in the ministry for roughly more than 10 years now. And the next version of it is actually going to be coming out in the next 1-2 years itself. We are still in consultation with both the asphalt industry and also the concrete industry, because these are the two main industry that provide input into our green pave. Because at the ministry, one process in our bidding is that we actually, for a lot of the more major projects, we allow what we call AB bid environment, which means you can either bid a highway construction as concrete or asphalt alternative. But because of the AB bid criteria itself, life cycle costing is definitely one of the major factor used, as I said, but then also the green pave on top of it is what we will use internally. Although the contractor that do a lot of this major project will be doing it under AFP environment where they make most of those decisions. But then if you drill down to the specification that we attach to those contract itself, it also will lead you to actually selecting something that will be more environmentally acceptable to our ministry, because it is inherent in our spec. We are driving you to that direction, whether you like it or not, because although there is a certain leeway for you, but a lot of the specification, in order for you to comply to it, will lead you to actually going to something that is environmentally more acceptable for the ministry too. I guess in terms of the green pave itself, as I say, it went through few stages itself. Initially, we went for consultation, and because it involves multiple industry itself, it took us about 3-4 years of consultation before we can get agreement from both parties for the first version of the green pave. And basically, I'm actually quite reluctant to go back and reopen it for the next generation, because that will be another 3 years of my life to basically get both of those industries to agree to something. But unfortunately, with passage of time, EPDs and all those things are all coming in, and also technology have changed. So we actually have to incorporate a lot of this newer technology, the environmental product declaration point system. So all those things are going to be incorporated in the new green pave system that we are actually going to roll out, hopefully in 2-3 years. By that time, I think I can safely say I likely will be in Brisbane by the beach. As indicated itself, this is actually a process of how the ministry look at the green pave itself. First, at the design stage, we actually will, at the design stage, the pavement section, my section will actually assist the regional geotech itself when they look at different pavement alternative and everything. We will do an initial assessment of what is the green pave rating based on just the theoretical design itself. But then, in order for the green pave to be more encompassing, you actually need to, because what you design is nice on paper and in drawing, what the contractor construct may not be exactly to your drawing and your specification itself. So based on taking testing and sampling of what is actually constructed, we actually will go in and re-rate the green pave. There's a number of components that is actually construction-based data. Based on those construction data, we input it in. So I can give you a project initially at design stage, what is the rating, but it's probably 80 out of 100 mark itself. After you construct, the other 20% mark will be added onto to see what is the real final rating of that project. Initially, we did not do that for every project, but in the ministry, we have done about 500 projects where we actually green pave rated at design stage, which means we have selected the strategy, the pavement design are selected, and asphalt type, granular type, and everything is spec in terms of thickness and everything. So we roughly know, based on that design, roughly what is the green pave rating system. Let's say 80 out of the 100 mark itself, what you are going to rate based on that alone. Because as I say, in order for you to do the real nitty-gritty of after constructed, it actually is a much more involved stage. Is because in terms of green pave rating system, I come from a background after leaving the private industry. I actually started 7 firms in doing carbon credit in Asia itself. If you want me to do carbon emission rating of a project, I would want to use UNFCCC protocol to rate it, which means not only are you actually going to design stage quantify it, I'm going to make you do a lot of testing and quantification during construction so that what you claim is exactly what you get, rather than just based on design. Based on design, you get a certain rating, but how is that translate into a real project? Not exactly. Whereas if you use the UNFCCC protocol, every parameter that you want to claim a carbon tonnage, you actually have to verify it or actually measure it. By that process is a much more rigorous process, but on the flip side, that process will require from $200,000 to $1 million in monitoring and quantification, which is something that you would not want to do unless your project contain a lot of carbon emission. Because I would say 10 years ago, if you are in the carbon business, 1 ton of carbon is 30 euro. And some of those projects that I generally deal with are 200,000-300,000 tons a year for 20 years. If 200,000 tons at $30 a ton, that's $6 million worth of carbon credit. To spend $1 million is not a problem because I still pocket $5 million. But unfortunately nowadays, if you look at Canada, our carbon pricing is already around $30 and actually increasing. So in that sense, a lot of the project itself, there is actually a value on the carbon side. depending on what you choose, and as I said, based on the ministry green PAVE rating, we tend to basically choose project that will give me the biggest footprint reduction. That implies there is a direct carbon footprint dollar value that can be attached to it, that can be monetized. Because the moment you monetize the carbon asset, it totally changed the game. As I said, when I first left TRO, which is EXP now, my first project is actually, I'm a road engineer, but my first project in the carbon business is that I actually took over a landfill in China and actually do a gas capture of the methane gas, because methane is 21 ton equivalent in carbon. That landfill generates about 150,000 tons of methane itself, carbon credit. At $30 a ton, that's a significant amount of money. My investment is $1.5 million. But then from that day onward, every year I get 150,000 tons of carbon credit at $30. And that's the deal that I signed with the government itself. They thought they have a good deal that I actually booked the gas collection and power generation and give them the power for free. But later on, when they found out that I'm actually pocketing $3 or $4 million a year, they actually want to pull that contract out. But I'm saying, sorry, you already signed it for 20 years. So I guess in that sense, this is the aspect of why I'm saying that the moment you actually have a carbon asset attached to a project and you can monetize it, that totally changed the life cycle costing and the project initiative. What if I tell you if this $1.2 million project itself have, let's say, $500,000 worth of carbon footprint that you can get back? Well, you just have a reduction of $500,000 in price, especially if you are on the owner side. Because generally, the carbon business itself is whoever owns the carbon right can monetize it. And in this case, a lot of project belongs to the government entity. Technically, the government entity, all they have to do is get a certified consultant that certified this is the real reduction in carbon. That piece of paper now you can actually sell it to any of those polluting companies that have a lot of pollution that they want to reduce their carbon footprint. That piece of paper can be used to reduce their carbon footprint. And that is how basically in theory some of the major polluters can get to net zero. It's like they are buying pieces of paper that other people are reducing carbon footprint to use that to reduce their carbon footprint. Because of that, I think it is quite an interesting concept that the ministry have gone this route, whereby we are quantifying emissions and rating the project itself. I think that will lend a lot of the other government agencies to look at, is this one way that we can help to finance a project itself? Because if for a certain project where you have very high tonnage of raw material that you have to import, by using recycle, your footprint will reduce tremendously, because as most people know, if you want to crush aggregate, there's a lot of energy involved in crushing the aggregate, and to produce out the hot mix itself, if it's lesser in AC and everything, there are carbon footprint associated with all these different components. And if your carbon footprint is big enough in terms of that project, as I said, there is significant dollar value attached to the carbon component, which most agencies have not even looked at it to monetize it. Because I've been trying to get the ministry to monetize it for the last 5 years and help them to do it as long as Stephen Lee get his cut. But I don't think I'm allowed. Because it is not something that they are used to, that how can you actually generate a monetary item out of something from just a piece of certification that you actually do the reduction. So in that sense, a lot of people have a hard time getting over that hurdle. But I'm saying if you want to get over that hurdle, go to Asia, go to Europe, where a lot of those companies have been buying all those carbon credit under Kyoto Protocol itself, and that is reality. Multi-million of dollars has changed hands because of those carbon. As I say, in the ministry, we actually developed Green PAVE, and for anyone that is interested, we actually have a resource reference menu and a software that we developed that will help you actually do the rating itself, and contact me or my staff and we can make that available to you. This is just an example where we show the one in blue itself. If you look at it, the life cycle costing is higher, But because of the environmental rating under green pave is better, we actually select that alternative on that project rather than the one with the lowest life cycle costing. So that is actually how this translates to the environmental impact. The higher impact itself actually translated into how we actually select that project itself. As indicated, discussed before itself, at the ministry we have been quite an early adopter in actually using recycling. In aggregate, there's a number of specifications that we allow and the percentage of how we allow recycling in aggregate, in asphalt, in concrete. Basically all the material that we use in construction of the roadway, there are specifications related to it that we actually allow the recycling. And it is an ongoing learning experience even for the ministry, because with newer technology and newer material, the thing that start to evolve, the percentage of what we allow also evolve. In terms of recycled concrete, of late, we actually on some project allow 100% of recycled concrete into the concrete that we use on some project as a trial NSSP, so we learn from that, and based on that, do we need to modify further before we make it go into the mainstream spec. Similarly, in the cold asphalt technology, I'm basically quite heavily involved, whereby I'm using 100% wrap itself to actually form 100% coal plant mix, because what I've been approached is that a lot of plant is saying, listen, Stephen Lee, asphalt plant wrap pile is growing like crazy. What is the way that we can actually use it? And my assumption is that if you are the industry, you want the highest value for that wrap. Well, the highest value for that wrap, technically you can put it into a hot mix, but hot mix itself in MTO is very stringent. Our surface cost is almost impossible for you to meet in a wrap pile, because if your wrap pile get contaminated with any other material, you cannot use it on MTO surface cost, because our surface cost is designed to have very high frictional property, which is only can be granted using virgin aggregate most of the time. Because when you do at very high speed and you don't have the friction, it's a bad combination. The liability is way too high. That's the reason why at the ministry, we actually paused the use of recycle at the surface cost for a while. But as we speak, we are actually opening that up on a few projects where we use newer testing method and newer quality assurance process to allow back some wrap on some of the project on trial to see how far we can push this itself. But as I said, from where I'm sitting, the initiative that I've taken in the last 2-3 years, that how do you like it if I let you use 100% of the wrap in a co-mix? That co-mix will be put down right on top of my granular as the base asphalt, because at the base asphalt concept, I don't need the quality to be as high as wear cost and everything. So that is an easy win for you. The gradation requirement is not as stringent. The asphalt requirement is not as stringent, but there is a requirement that I want. Your wrap pile, you need to homogenize it for me, because I want that one design to be good for 10,000 ton or 20,000 ton of the wrap. I don't want to be basically every time you dig into a different pile of your wrap, I have a different mix design. That does not work for the ministry. So I'm saying I'm willing to basically go halfway. You want to do my project, if it's 200,000 ton, maybe 20,000 ton of wrap, you actually make it, homogenize it. Based on that test result, we actually will make you do a mixed design, or if you want to homogenize 100,000 ton, we are game. But the wrap needs to be homogenized in a co-mix environment, is because in co-mix, the requirement is the co-mix go down at 10 to 15% air void. So it is actually a relatively not as dense a mix as your hot mix. Your hot mix has 4% air void. I want the 10 to 15% air void, if 12 to 15% air void, is because I want that layer to be stress relieving, crack relieving. When you actually are very dense, you lose that property. So the co-mix have its own uniqueness, but then if you look at most agencies, if you look at how they design pavement, everyone know how to design asphalt on top of granular. If I ask you to design asphalt co-mix on top of granular, then hot mix on top of co-mix, Tell me who know how to design that properly. I can tell you, I've talked to numerous, even US state dot and everything, none of them know how to design it properly. Because the first mistake they make is they assume that the cold mix is behave like the hot mix. I can guarantee you the cold mix doesn't behave like the hot mix. The cold mix itself is a different animal. Guess what? The latest technology that I'm trying to look at is using gel asphalt with the cold mix. I can produce that gel asphalt cold mix and put it aside in my asphalt plant for 1-2 years. 2 years later, I can dig into it and ship it and actually still place it. That cannot be done with hot mix, but that can be done with cold mix, which means I can produce significant tonnage of this thing, and everybody know what is the quality, quantity that can be used. Use it whenever you need. That is the flexibility of some of this kind of technology that is coming. I think we are pushing the boundary at the ministry, but not only that, we are saying you need the new design method, and in fact, I'm actually working with my staff whereby we are quantifying this material totally different, but the design aspect is also different. The construction need to put on a different thinking hat, because when I place the cold mix is not meant to be a surface cost. It is a temporary traffic staging cost. The moment I put hot mix on top of the cold mix, the hot mix underneath start to develop in tremendous amount of strength. Cold mix initially when I put down is 250 kPa. The moment I put one layer of hot mix on top and compact it, that cold mix now shoots up to 250 to 300 kPa. 5-10 years from now, when you test that cold mix again, that cold mix is now at 500 kPa. Guess what? As we now go to any designer in the industry and even in the state, they assume the cold mix to be 250 kPa. The day that I place it down, 10 years later from now, they still assume as 250. But as I said, at the ministry, we have 30 years of experience with in-place recycling. Call this material, test it, we know it's totally different. But guess what? If you have something that is 250 kPa, now have 500 kPa, the strength have double. Do I still need the same thickness of my pavement design? Likely not. There is the saving, which means when you actually use the newer technology, newer design process, you will find more efficiency in your design. But environmentally, it's a much more friendlier solution. As I said, the cold mix is much easier to make than a hot mix, and the physical requirement is much lower than hot mix. So it's much easier for the contractor to produce. But in ministry project, the two that we have done, we are paying close to about 80% of a hot mix for the price. So to the ministry, there's a cost saving. To the contractor, do you want to sell that aggregate at $12 a ton, or do you want to sell it at $60 a ton for us as a cold mix? Up to you. So in that sense, there are a lot of different technology that are now coming together when we are looking at it from the environmental perspective. It required us to change our design method, our thinking, because some of the technology that is coming will definitely impact how we actually, if you want to be environmentally sustainable, some of these tools will definitely change the way we do business. As I say, in terms of the specification itself, the ministry specification will keep evolving, because as I said, with all these changes coming and everything, we are forced to basically do a lot of R&D. Based on the R&D result and data that we collect, we actually will go in and change the specification. And to be fair, at the ministry, as indicated by some of the municipal engineer here itself, some of the scale of our project is much larger, but when you're at a smaller scale, you actually have to modify the spec to suit your need, because you may not be able to do what we are doing because the scale is different. Timing afforded to us may not be afforded to you. I can afford to wait 1-2 weeks for the test, is because my project is going to be 1 year long or 2 seasons long. I can afford to wait a month for the result to come in before I make changes or decision something. Whereas if your project is only 1-2 months in cycle, to wait 1 month for result and make decision, that doesn't make it very manageable. So those are some of the adaptation that I think a lot of you all will have to look based on your environment setting and based on the ministry, what can or cannot be done, and the project of scale have a different potential that you can do things that you may not be able to do if your scale is not there. As I say in the ministry, aggregate sustainability, we now look at different way that we can actually recycle aggregate itself, and in terms of recycled concrete, the ministry that now basically literally allows 100% of recycled concrete into our aggregate itself. Even B type 2, we are starting to experiment with some project where the ministry actually specified B type 2 should be 100% quarry crush aggregate. We are starting to introduce recycled concrete into some of those projects on limited basis because we realize sooner or later we have to transition that into that itself. And as I say, aggregate conservation is a big thing, is because ultimately, as I indicated, some of our project we have aggregate barging from the US through Hamilton Port to our project. Well, that is not very sustainable. And as I say, on some project we are shipping aggregate from Quebec to our 400 series highway project in western part of Ontario. That is also not very sustainable to have all these hauling trucks from Quebec coming in to supply the aggregate. So because of that, we are really looking to whatever way that we can to minimize the use of this because premium aggregate is actually in short supply. And we are actually going further and further to get the premium aggregate for our application. As I say in the ministry, your 400 series highway, you want the best possible premium aggregate on it, is because there's 400,000 cars on the busiest part of your 401. If you have potential for accident in terms of friction property, that is the worst place you want to have a problem. And that is the reason why for a lot of the ministry application, the 400 series highway have very high aggregate requirement where does not lend itself as much to recycling because our friction demand is very high. And guess what? There's already a directive of some of the highway, we are actually increasing the speed from 100 to 110. The moment you increase the speed and with volume, well, you better have a pavement that have very high friction property. But due to climate change, these are also coming into play. What we are seeing is that the rain are coming down at such high intensity. Total quantity is the same, but it's coming down at such high intensity. The water are not running off completely off the highway, and you have a minor ponding on the highway. When you have minor ponding on your road surface, friction doesn't matter anymore because your tire is actually floating on water. It's not even touching the pavement itself, and that is a totally different phenomenon. And at the ministry, we are simulating some of the project. What is the impact of climate change and what is the change in design we need to do. Cross slope, the ministry have looked at changing it even at the TAC to change the cross slope because of climate change. Frictional management, in fact, I'm actually in the midst of writing a brand new policy of friction itself because we are also saying with this new climate change, there is an impact, and how do we mitigate it and be ahead of the game rather than waiting for accident to happen, then deal with it. As I indicated, the wrap use itself, traditional ministry have been using wrap in all our asphalt itself for quite a long time. But one of the newest use is actually, as I say, is the 100% cold wrap plant mix rather than in-place recycling. Ministry have been doing in-place recycling for 30 years. And there are a lot of differences itself in the sense that in-place recycling, straight away you are recycling the ministry highway where we know the quality of that asphalt is a certain amount as long as I don't go to the base layer. Whereas plant mix itself, it's all depending on the wrap pile that you have and how you manage that wrap in order for me to come up with a design that will meet all our specifications. So that actually is the new area that we are delving in. As I said, reclaimed concrete itself, we have been doing it for quite a while, and as we speak right now, we are trying to open it up to more application, and even, as I say, even in concrete, 100% in concrete itself, application with some additional testing and quality assurance. Supplementary material, the ministry is also looking at other users of ceramic, glass, tires. So in that sense, we are actually open to looking at recycling material to basically aid the reduction of some of these material that, if you don't use it, it actually will need to be landfill, and that actually is a significant cost. And if we can use it at limited quantity and actually can control the engineering property, as I said, the ministry, the overarching thing in terms of how we look at any material for engineering purposes is that as long as I define what is the engineering property for that road or highway, we are game at looking at any other option to change it as long as the engineering property is still preserved, because that actually will give me the assurance of durability, give me the assurance of safety, give me the assurance of life cycle costing makes sense. But on top of it, if it is also environmentally sustainable, that would be a plus. As I say, alternative material, we have looked at quite a lot of different alternative material and even the new arc ignition blast furnace rather than the old traditional blast furnace itself. Rubber tire, one project, we actually used 400,000 ton on 2 embankment. The challenge with that itself is you'll be shocked, because we used 400,000 tire on that project. The project was thinking of sourcing additional tire from US because they could not supply all those from that one pile that they have. And that to us at the ministry, that is not acceptable, because we want your tire to come from Ontario. I don't want to basically recycle US tire on my behalf on our roadway. So some of this we actually, as I said, with any trial, sometimes you face challenges, but this technology have also changed tremendously. The initial tire shredding, and I think it's a mechanical shredding. As we speak right now, they are using cryogenic shredding of the tire, which means they freeze it to very high temperature, they drop it or hit it, and it actually will shatter. Whereas initially when we did this, we was actually mechanical shredding. If you mechanically shred the tire, and especially a lot of our tire contains steel wire and everything itself, it's a challenge. To get the gradation that you want and to get the quality that you want was a challenge. And that is the reason why we actually right now have slowed down the use of tire-derived aggregate, is because I think unless we know that a producer can produce the quantity that we want, it actually impact our project deliveries, because halfway through the project you run out of the tire pile, and then we now negotiate where are those tires coming from. Is it from the state or from Alberta or Quebec? We have a problem. As I say, in terms of asphalt pavement recycling, ministry has been at it for almost 40 years, and a lot of the in-place recycling and a lot of the hot mix recycling has been well established in the OPSS and everything itself. We are looking at using newer generation of testing to quantify the asphalt itself, because right now the normal asphalt pavement design is great in terms of it is a virgin asphalt binder. The moment now you have aged asphalt binder, the test method and everything are not the best. And it's very hard to do mixed design and also final end product quantification of how long it will last and everything. It's not as simple. Can be done to some extent, but we need improvisation of the method that we do the testing. And we are looking at nuclear method of actually looking at the molecular, how it is going to age. So we are actually using quite a lot of new technology to augment the current technology itself. Likely a lot of them are based on the nuclear science, because the nuclear physics itself, you can actually look at your material particle or the chain in a molecular level to see where the oxidation or the change in state happen. Whereas our traditional method of chemical testing and all those things cannot quantify those things as gracefully. So those are the area of research the ministry is doing, and I'm actually also doing a lot of those research for the in-place recycling, the cold technology using the nuclear method itself. As indicated itself, right now a lot of the asphalt recycling is not at the surface wear cost. As I indicated, the surface wear costs have some restriction, but binder cost definitely is not a problem itself. And cold mix, definitely we actually are changing in the ministry, I'm actually mandating my pavement section designer, if it's a brand new highway, look at actually putting in a cold mix technology asphalt as the first lift, and top it up with hot mix is the way that we are designing the pavement. And in terms of in-place recycling, as I said, I know, when I'm in Ottawa Carlton, the first in-place recycling happened in Ottawa Carlton. The next year, MTO started the in-place recycling in 1989. That tells you I'm probably around 40 years in this business itself. Sooner or later, I think it's time the newer generation take over some of this file. Because in-place recycling definitely have its place because it actually saves a lot of trucking. It also conserves a lot of material. In-place recycling, you are using 100% of the in-place material. Both, even is concrete, we are starting to look at rubberizing and all those things of our concrete pavement because the 4-hole one in the whole of Toronto from one end to the other in Central Region, the middle 2-lane is composite pavement with the concrete buried about 300 mm below all those asphalt. But guess what? Those concrete are now 60 to 70 years old. All the joints are probably short. And in fact, if you just shave and pave the asphalt off, the crack is going to just reflect right back up on you because the concrete joints are actually the problem, not the asphalt. And as I say at the ministry, one of the quite environmentally in place recycling is the full depth reclamation, where we powerize the thing to become 50% wrap, 50% granular. Cold in place recycling is that we just recycle just a layer of the hot asphalt itself and turn it into cold asphalt. Then we top it up with hot mix on top. Because of the knowledge we gained from the cold in place recycling that we had done for the last 30 years is why I'm actually doing the cold plant mixes, because what we are finding out, if you basically put hot mix on top of cold mix itself, it actually outperforms a pavement you design with strictly hot mix on hot mix. That is the reason why I'm a strong believer in using the cold plant mix technology, because it actually is identical to this, with the exception in plant mix you are dealing with the wrap pile that you have in your plant, whereas in the in-place recycling, the ministry highway, I exactly know what is my surface cost is. That's the major difference, and that is one area we need to work with industry to ensure that they are willing to homogenize their wrap pile. Then I can see an equivalency. As I indicated, this is a Highway 3. That one project, I'm not sure, we probably used close to maybe 100,000 ton of the coal wrap itself. But this year we are actually trying a much larger project itself where we are also using the coal mix technology. But as I say, I'm also looking at gel technology. That is also a coal mix, but it's a European technology whereby you can make that mix and then you actually can stockpile it for 2-3 years and dig into it and actually reuse it as a coal mix as you go. It's a technology that is used in Asia and Europe, but guess what? Not used it too much in North America yet. And I think we hope to change that. Hot in place recycling, the ministry have gone back to hot in place recycling. 30-something years ago, I did quite a lot of hot in place recycling. But the hot in place recycling we did in Ottawa Carlton is the remixing hot in place recycling. MTO used to do a repaving hot in place recycling. Major difference is that MTO used to do hot in place recycling. You must put a lift of hot mix on top of the hot in place recycling. Remixing is that I'm actually recycling your top surface layer of your hot mix. It comes back as your surface wear cost, which means I don't need to put the extra layer of hot mix on top. Because of that, the cost efficiency is much higher. But not only that, because of that, the requirement is much higher on your equipment, which means your equipment must weigh the wrap, must meter the rejuvenator, must meter the remixing admixture you're going to add into the hot in place recycling in order for you to meet the surface cost quality. We are asking you to meet surface cost quality. We are not asking you for a base asphalt. That's the major difference. But if it's done properly with the right equipment and technique, there's a huge cost efficiency, and the ministry is still pursuing this. Although we have some growing pain with this when you use older machine, but we hope to transition to the latest newer technology itself. In a nutshell, this is basically roughly the quantity of in-place recycling that the ministry do over the years. And significant amount of our project are actually done. 1-point-something million ton a year of mix are actually in place recycling, not including the other hot in place and the hot surface cost and the other technique that we use. And in terms of environmental emission, the ministry generally, when we do a project, this is actually 2 projects. The top 2 is 1 project. The bottom 3 is a different project. We actually use the Palette software, as I said, modify a bit, and we actually calculate the emission of that project itself. And based on that, we look at the 2 alternatives, mill and pave versus hot and place recycling on the first project. Hot and place recycling definitely have a much smaller greenhouse gas emission. And then based on the next project itself, mill and pave tree lift, CIREM, CIR. CIREM and CIR relatively same amount of carbon footprint, whereas the mill and pave tree lift have significant amount of greenhouse gas. And as I said, if you are the agency and suddenly you basically start to certify this, get a consultant certify the carbon reduction, guess what? That carbon reduction, as I said, I think the federal government carbon pricing right now it was $30 a ton before, but I believe it's going to increase to maybe 40 or 50, and then going to be higher still in the future. There are huge dollars attached to some of this project if done properly. And to be fair, as the agency, that actually will come back to your bottom line of the financing of the project will be much cheaper because you actually have this piece of carbon asset, which if you don't quantify it and don't certify it, that asset is lost. I guess in a nutshell, I'm just not going to go through this itself. I probably can take questions. Thank you.